So that's what we're trying to understand. What in the environment, what in the weather, what weather patterns, what soil nutrient content, what type of precipitation levels, what type of soil moisture levels are going to be more conducive to outbreaks. And on top of that, we have interactions with insects. When there are outbreaks of insect infestations, caterpillars, that's normally followed by an aflatoxin outbreak, an aflatoxin contamination outbreak.
Hi, welcome back to the Dairy Podcast Show, brought to you by 𝗦𝗽𝗁𝑥. My name is 𝗵𝗫𝗀𝗏𝑟d from Michigan State University, and today I'm honored to welcome to the show Dr. Lina Castano-Duque. Lina is a plant pathologist at the Food and Feed Safety Research Unit in the Southern Regional Research Center in New Orleans within the USDA Agricultural Research Service. So Lina, thank you so much for joining us today.
Oh, thank you so much, Barry. I'm excited. I am looking forward to the conversation.
I've been to New Orleans once or twice. Unfortunately, I usually land there in the summer, which is not my first choice, but I'm looking outside now. It's like pretty close to zero wind chill, and I'm kind of jealous that you're in New Orleans. What's the weather like there today?
Hey, it's 54.
Okay, yeah. I need to figure out how to get there in the winter.
For me, 54 is cold.
Yeah.
But that's because New Orleans, anything below 50, you will see people in parkas and beanies and gloves. We like it warm down here.
So did you grow up in a warm environment? Where are you from originally?
Yes, I was born in Colombia.
Okay.
So, and I was born in the southern part of Colombia. So we didn't have winters. It's all like tropical weather. So the only weather seasonality we had was just like, okay, it's gonna rain or it's going to be dry. That was it. So it was always warm. It's considered like the never-ending spring kind of situation, the city where I was born. So
rough.
Yeah, not a winter person myself.
Well, and maybe that's partly why you ended up being an expert on mycotoxins, right?
Well,
one of the trade-offs of being in warm environments is lots of things grow.
I know, yeah. The fungus likes it at a very specific temperatures, but it's very resilient. It can survive the cold weather. It overwinters very well. So
is that right? Okay.
Yeah.
Well, let's back up. How did you end up, probably most people in second grade don't say, I want to study funguses. How did you end up here?
Oh, well, no, in second grade, I remember thinking I want to be a doctor, like a medical doctor. And it wasn't probably around fifth grade when I realized I don't like blood, and the idea of touching sick people terrified me. So I was like, yeah, probably not for me. So I remember thinking I do enjoy genetics and science. That's something I wanted to do. So my mom took me to one of the local universities. A friend of us was a professor there, sat down and talked, and she said, well, if you like genetics, if you like science, chemistry, you don't need to become a medical doctor to be a scientist. You could just go and learn biology, learn chemistry, and then you could go to grad school and become a scientist. There are options. So I was like, okay, that's what I want to do. So that's how it started. I think my journey to fungus has definitely been a winding road, I want to say. I started working with insects, plant and insect interactions.
Okay.
And then at some point I realized, it's in the real world out there in the fields is not just the plants and the insects, it's the microbes, is the weather, it's everything happening at once. So that's how I end up in this area.
Oh, that's fascinating. So you went through plant pathology graduate work, I assume?
Plant biology,
Plant
more
biology.
general.
Where did you do that work?
Penn State, Pennsylvania
Okay.
State University, in a state college, also well known as Happy Valley.
Yes. So you did experience some cold.
Oh yes, 7 years that I'd say to myself, never again.
Okay, and then how long have you been with ARS?
So I started with ARS at the end of 2019. I want to say around Thanksgiving 2019.
Okay.
And I started as a postdoc, and then I was at the right place at the right time, and I applied for a permanent scientist position, and it worked out.
Introducing 𝗟𝗏 𝗟3.0, Volac's comprehensive and complete solution to reduce the negative impact of naturally occurring toxins on ruminants. 𝗟𝗏 𝗟3.0 is a species-specific product designed to mitigate the effects of specific mycotoxins in the gastrointestinal tract of ruminants. 𝗟𝗏 𝗟3.0 also offers lipopolysaccharides binding capabilities. Endotoxins such as LPS can contribute to inflammation in ruminants, with energy partitioned to mount an immune response instead of production. Learn more about 𝗟𝗏 𝗟3.0 at volac.com.
Well, most of the people listen to this podcast focus on dairy production, which has obviously many aspects. Is a little bit like that complex interaction of 50 things like you're talking about in the plant environment, right?
Mm-hmm.
And many people are aware of mycotoxins at some level. Typically, when animals are not performing well or it's been a bad crop year, it comes up as a topic and kind of assess whether it's an issue or not, and then move on to one of the other 50 things to worry about. But maybe you can help us with some kind of basic understanding of what's the kind of scenario that drives growth of the funguses that mostly cause mycotoxins. How does it even start?
Yeah, so I like to think about it like in a very like when you think about yourself as a person. You normally have a particular way where you like things. Like let's say you have your thermostat at your house, and you like your house at a very specific temperature because that's how you feel good. That's how you enjoy your day. You unwind at your house, or that's
Right.
you. So that's very similar situation with the fungus. The fungus can grow and be happy in terms of nutritional acquisition, and just in general not be stressed out. It's not too cold, it's not too hot. So the fungus likes it at a very particular weather and location. So that's kind of where the environment plays such a big role in the fungal populations in the fields. So, for example, 𝗟𝗶𝘀𝗃𝗃 has an optimal temperature of around 30 degrees Celsius.
Okay.
So at that temperature, it grows the best, high rate of growth. It can produce the most amount of toxins, and it can move around and infect different areas on a farm. So that's kind of where the whole environment temperature plays such a big role in the fungus being happy in terms of the metabolism, in terms of finding a home and being able to reproduce and move.
Okay, that makes sense. So 30 degrees Celsius, about 86 Fahrenheit is an example, but there's different species, right, that can contribute. What it's maybe not an easy question to answer. I don't know, but is there a certain number of fungal species that are the biggest concern, at least in the U.S. context?
That's a great question. It's actually that's an area of active research right now in my lab and in my collaborator's lab. So my collaborator works on Fusarium species. I work on Aspergillus species, and we are looking at different Aspergillus flavus types that grow and are very abundant in different areas of the United States. So this fungus is everywhere. You take an amount of soil from your farm or from your house, you probably are going to find some sort of aspergillus is
Okay.
there.
Yeah.
Now, the difference is some of the types of Aspergillus can produce aflatoxin and some of them cannot. And the ones that produce the aflatoxin, those are the ones that they can be in different locations in the US. So, for example, right now we're studying some of the strains of Aspergillus flavus that are very abundant in the southern part of the US, in the center part of the Corn Belt. And we are just starting to work with a strain of Aspergillus flavus that produces aflatoxin that was found in Pennsylvania. So this fungus is everywhere. Um, and, and depending on where they are found, so let's say Pennsylvania versus Arizona or Texas, they like different levels of temperature. Some of them are happier in terms of growth at 30, and the Pennsylvania one seems to be happier at 25 Celsius. So you can see that it's like they have adapted to different regions in the US. So it does make a big difference of the type of Aspergillus, that the species, where it's located, where it could be present in which farms.
I think it's an important point you said. If you know, with the modern DNA detection technologies we have, you can find evidence of these things kind of anywhere, right? Like they're everywhere. So if that's true, why do we talk about the term mycotoxin outbreaks? Like, you know, the fungus is always there. Are the toxins not always there? What makes that difference?
That's $1 million question.
Yeah.
What makes it perfect for the fungus to create an outbreak of the contamination? That's what I study. If I had 100% an answer, we will solve the problem.
Yeah.
So that's what we're trying to understand. What in the environment, what in the weather, what weather patterns, what soil nutrient content, what type of precipitation levels, what type of soil moisture levels are going to be more conducive to outbreaks. And on top of that, we have interactions with insects. When there are outbreaks of insect infestations, caterpillars, that's normally followed by an aflatoxin outbreak, an aflatoxin contamination outbreak. It's a matter of the fungus is present, but if the environment is hot and then it becomes very humid, and that happens around the time that there was a caterpillar outbreak, it's like the caterpillar creates an injury in the corn, and that injury is open and it's there, and it's like, oh, look, there is a delicious amount of starch and lipids and fats all there for you, Mr. Fungus, to grow. So the environment is perfect now. Come, grow, proliferate. And that's at that particular environment, at that particular point, is when the fungus makes a lot of aflatoxin.
I don't know if there's a clear answer to this either, but I guess in my mind, one question would be, if we have a lot of viral load, so if you have a condition that allows the virus to replicate and have a huge, number of viruses, does that always lead to high mycotoxins, or is there also a phenotypic switch where sometimes the virus makes toxins and sometimes it doesn't?
That's also $1 million question because sometimes you can have the fungus growing, proliferating a lot.
Oh, I said virus. Sorry, fungus. Yes,
it can grow a lot, but it might not be producing enough or very low amount of aflatoxin, and it might be a switch that we don't really know what that switch exactly is, where the fungus becomes stressed enough that it starts making the toxin. The reality is these toxins are extremely dangerous for us as humans, but we don't fully understand the role that they play for the fungus. Why are they making them?
Okay.
There is a lot of research that says, well, they are antioxidants for the fungus, or they might be signaling molecules that tells the fungus to switch from this to do that. There might be a source of carbon as well for nutrients. So we don't really know 100% what the toxins do to the fungus. All we know for certain is that they're very bad for human and animal consumption.
So there's a lot to learn still. Job security seems to come up a lot when you talk to scientists.
So that is true.
All right. So one of your major efforts that would have, a lot of potential implications for people running or helping manage dairy farms would be the ability to sort of predict, because especially in the last 5 years, there's been a lot of interest in what's the return on investment for application of antifungal agents on a crop, right? It's not only the cost of the chemicals, but it requires another pass through or fly over of a field, and that's a real investment. And it's been hard from an animal, like if you have an integrated crop livestock system, it's, more yield is always good, but that's not always a response to application, right? And you'd really like to know what's the net impact at the whole operation. Like, do we actually see better performance of the animals? And those studies are hard to do. So all the way back to that leads to this, like, how can we get better at understanding if these kind of applications are cost effective? And I know you're working on some predictive modeling efforts. Help us understand that, if you would.
Yes, of course. So for us, for USDA-ARS, which is the branch of government that I work with, we directly try to answer needs from our stakeholders. So several years ago, the National Corn Growers Association expressed their concern about how can we have some sort of alert system and some sort of predictive modeling for the farmers, for the stakeholders, to make decisions that might affect economical value and net gross income from their farms. So this came from that need, and we started to explore the creation of these models and trying to look at what level of prediction can we do, and in addition to that prediction, can we understand all these factors that are influencing an outbreak to take place or not to take place. So those were the two main goals, right? So the idea is, can we generate a prediction about 3 months before harvest time that says, okay, you are in, let's say, County X in Texas or County Y in Illinois. We can tell you right now you have a probability of an outbreak in your county of like 98% or 10%. So the chances of you having an issue are quite high. And there might be some integrated pest management practices that you could use to decrease that risk probability. So that's one of the things that were our goal. And the second goal is, okay, we have developed these models using machine learning, artificial intelligence, neural networks. Now, underneath the hood of the model, the fancy probabilities and all of that, we can look and say, what are the importance of all the input features that went into training this model? For example, precipitation in January or February, specific weeks of the year, or perhaps the risk index in March or in October might make a high influencer in that probability risk that we're generating. And that's the kind of things that we're trying to understand. To give you an example, our model right now, our latest model, which is for Texas, when we look under the hood, we found that calcium carbonate happens to be one of the highly influential variables. So what is calcium carbonate? It's the level of calcium present in the soil. You see, when we're modeling, we don't tell the model, hey, this is the history of management practices that have happened in this area. No, we just tell them, these are the levels of calcium carbonate. Can you look at how related are they with the outbreak? To have a calcium carbonate as a highly influential variable is very important because it's corroborating what a lot of farmers already knew in terms of plant health. The addition of calcium in fields is something that has been used before in many different places, mostly for correction of pH in the soil.
Right.
So we know that if you are planting in an area that is very acidic, you have a higher probability of an outbreak. So that's the kind of information that if we're able to make it available for our stakeholders and explain when in the year you might want to look into the precipitation levels that you're having and the temperature, then our stakeholders or farmers might be able to make informed decisions based on criteria of what they would like to do with their farms.
Yeah, and that's obviously a very practical applied insight from the modeling efforts, as most people call calcium carbonate lime, right, in a field application. So it's a practice people are used to, but maybe never linked with mycotoxin risk. So that's interesting. I'm curious, being in the sort of northeastern corn belt. Well, we're probably not in the corn belt, but this part of the country, tar spot has been a major challenge in the last 5 or 10 years. And I know some of my Michigan State colleagues have participated in an effort to do something similar, and they have an app called Tar Spotter, which I think they're still working to make better. So are you familiar with that? And is that sort of like what you guys are working towards for the mycotoxin predictions?
Yes, I am familiar with Tar Spotter. I have heard some of the people you probably are talking about, your colleagues, give talks about Tar Spotter, how it works. It's really cool tool. So yes, we have a dashboard that is in the middle of being beta tested with some of our stakeholders and trying to generate a very functional application for people to have access that has a risk index level per week, that has a historic side to it, to be able to look at, okay, how does the precipitation change affected risk in your area. Is able to also show farmers and other stakeholders, okay, here is the levels of calcium carbonate or any other soil characteristic actually in your region, so you can make a decision in terms of these particular features and these particular practices. So yes, that's what we want.
Right.
Same thing,
Yeah.
but ours obviously will be for aflatoxin, fumonisins. The tar spotter is mostly for disease itself.
Right. Yeah. And tar spot doesn't really create mycotoxin problems as far as we know. Right. So, okay, that's fascinating. It's a good effort. I'm curious too. Certainly, animal scientists would have answers to this, but I'm curious from your perspective, from a U.S. holistic agriculture in general standpoint. What's the reason to spend money on mycotoxin outbreaks? Like, what's the biggest concerns about it?
Boils down to people cannot consume contaminated feed,
Yeah.
or anything that has gone through the food supply chain that has been exposed to contamination and it's above the limits that are allowed. So, for example, aflatoxin, there are legal limits that have been placed by the FDA. So if it's above certain threshold, this particular truckload of grain will not be allowed to go for human consumption.
Right.
It perhaps could go, depending on the contamination level, it could go to either needs to be completely discarded, or it could go to other functions, for example, for ethanol production or for feed of certain animals or for other byproducts that allow those legal limits where it's falling in the specific legal limit. So mycotoxins are extremely harmful to humans, and that's why these legal limits exist. That's for aflatoxin. For fumonisins, we have guidelines as well. No, there are no legals, but there are guidelines. But in terms of export, most of the places where corn is exported, the purchasing side requires this testing. It's not only inside the U.S. It's also for exporting purposes. So green elevators, when they're going with their product, they need to test that. So economically speaking, these mycotoxins they're very relevant. They will affect the economy, and they will also affect the human health.
Good answer. Yeah, and then I think the system kind of makes sense, but when we're working with ruminants, sometimes it causes problems because I'm sure, as you know, like if we say, okay, this load of corn has too much mycotoxin, we're going to divert it to ethanol production. Then typically the toxins are concentrated in the byproduct that we end up feeding to ruminants,
yes,
right? So
it's worse, yes.
Yes. Even though because of the rumen, with some of the mycotoxins, ruminants have some more tolerance. Sometimes it can be a big issue.
Yeah.
It's time for our famous three. Modern bacteria create biofilms, and biofilm-related issues are at the core of most culling reasons on modern dairy farms. AHV provides the only program for biofilm management in cows and calves. How much of your herd's potential gets choked out by biofilm each year? To learn more, visit www.ahvint.com/US.
Okay, well, fascinating. Thanks. I've learned a lot through this. All right, Lina. Now we've got the three questions we always throw at everybody. And if you don't have, I know you don't work on dairy per se, so you can adapt these to your discipline as you desire. But the first thing we ask people, what's your favorite technical book or resource? We usually say dairy.
Well, I mean, in terms of technical resource for dairy specific, I do read a lot of scientific articles, and there are some excellent scientific articles for modeling aflatoxin risk in dairy. So a lot of those are very useful for me as a modeler, as a plant pathologist. That is very useful.
Okay, good. What about your favorite book in general? It's outside of agriculture.
Well, it's so hard to select a single book. So I'm just going to select an author that I really like. Anything by 𝗽𝗍𝘃 Allende. I love all of her stuff.
Give us an example of a name of a book.
Like 𝗺● 𝗪𝗀 is one of them, and Retrato en Sepia. I'm sorry, they're in Spanish. She's a Spanish writer. All her work has been translated to many languages.
Okay, good.
Yes.
Good. All right. And what style? What style of books are those?
It's called magical realism.
Oh, yeah.
So it's very similar in the same vein as Gabriel Garcia Marquez, where there is a historical component associated with the narrative, but at the same time there is that magic component to it of maybe there is some sort of superstition in the family, is the history of a family, and this superstition is magical or whatever, something like that. So that's kind of where it's really, I like it.
I'm reading a collection of stories from Marquez right now. So yeah, I get what you're saying.
Yes.
All right. So last question. In your opinion, what sets a successful professional apart from someone who may not be as successful?
Well, that's a tough question. And I think that the majority of us humans, we are not a crazy genius, right? And I think that when you are not a crazy genius that can see patterns floating, in the sky,
yeah,
it's a lot of what is it called? Perspiration instead of inspiration. It's 70% perspiration, 30% inspiration. That's kind of how I feel about this. You can be very successful professional if you are able to put the hard work and be creative and follow those ideas that that might sound crazy, but they're interesting and you go for them. But all of these great ideas mean nothing if you don't put the work, if you don't try very hard, from logistical parts to actually the research part, all of that. I think that that makes a big difference between someone who is successful versus someone who is not successful.
I just saw a tagline this morning I never heard before. It's called "Eat the Frog."
What does that mean?
Apparently, it's maybe a Mark Twain quote or something.
Ah,
The idea is if your job is to eat the frog, the best thing to do is just to get started.
yeah.
And the point is, if you have a job that's flexible in what you do at any given time, the risk is the hard work always gets pushed back and then it doesn't get done. So like the point is, take on the most difficult task first thing in the day.
Yeah.
And in the long run, it's a huge impact.
Yeah, it's good advice.
Okay, well, our guest today has been Dr. Lina Castano-Duque. Thank you so much, Lina, for joining us today. I've enjoyed the conversation.
Thank you. Thank you so much for having me.
And I'm hoping within 10 years, you'll completely solve the mycotoxin problem that's been plaguing humanity for tens of thousands of years.
I don't know if that is possible, but
Maybe
at
not.
least we'll try to make it better.
I'm sure you'll make a difference. So thank you for your efforts.
Thank you. Thank you so much.
Well, this has been another episode of the 𝗟𝗃 Show. If you haven't liked or subscribed to this show, make sure you get that done so you don't miss the next episode. And with that, we'll sign off for today. We'll see you next time.